Today we're going to talk about law of cosines. We use law of cosines to solve for an oblique triangle. Let's talk about some of the other things that we've used for solving triangles. We started out with special right triangles, but as the name suggests, this only applies to right triangles that have these special angles, like 45, 45, 90, or 30, 60, 90. So then we used some right triangle trigonometry, and that helped us to solve other types of right triangles. When we got to oblique triangles, we said, okay, well, we can still solve these, but we're going to need law of sines. Now, law of sines worked for some types of cases that we could get, but not for all of them. So then we introduce law of cosines. And we'll talk about which cases the law of cosines applies to. So we have a triangle that's oblique, and we have our alpha, beta, gamma angles, and our sides ABC. Now, the law of cosines can be thought of as three separate formulas, but it really only need one, okay? And it's really arbitrary which one we pick, but let's talk about this one. So we see that we have all three sides are involved, so c squared equals a squared plus b squared minus 2ab times then the cosine of gamma. And notice that gamma is that angle that's opposite that side. So this kind of leading side here that has its own side of the equation is going to correspond with the angle inside the cosine. And then the other two sides show up twice, a squared plus b squared, and then the ab again here. You do not need to memorize this, so this will be part of your reference sheet provided on exams. But they're not going to give you all three, they're only going to give you one. And so you just want to make sure that you feel comfortable with kind of taking this one and looking at the structure and then being able to kind of think about the other two if need be. Let's look at the different cases that we can apply law of cosines to. So one is this side angle side. Now this means two sides and an angle, but the way that they're given is different, say, than SSA, right? It's not that one that we talked about with law of sines. So the SAS one means two sides and an included, this should say, angle. So let's talk about what that would look like. Okay, so this side, and then not the angle across from either of these sides, the one that is in between them. Okay, and so that's why we think of it as side, angle, side, because if we start at one thing and kind of go in that order, then we get that side, angle, side. And then the other case is side, side, side. That might be more kind of self-explanatory. So we're just given all three sides, but we're not given any of the angles at all. So why can't we use law of sines in these cases? Well, I think it helps to think about our alpha, beta, gamma, and then A, B, C. So let's talk about, so for the SAS, we are given two sides. So let's say it's just A and B, but then we're given the side included, but we're given the angle included between them, and the angle included between them can't be alpha or beta because those are the angles that are across from them. So in between them has to be that angle gamma. Now, if we try to make law of sines here, we know we need like 4 pieces for law of sines to set up a law of sines equation. So if we try to do that, let's say we picked these two. Now we have 2 unknowns. That's not going to work. And then any way we try to box that out to grab 2 of those pairs, we'd always have 2 unknowns, and so it's not enough. And then you could probably see that happening if I tried it with a side. Okay, if we just knew the sides, then any way I try to say grab 4 of them together, like these 2 pairs, I'm always going to have 2 unknowns, so I can't use law of sines.